Process of electrophoresis involves the use of a chromatographic Wattman paper, which is cut into a definite size, approximately 1 into 20 centimeter. A pencil line is drawn perpendicular to the length of the paper. Samples are then applied to the positions marked on the line. A similar spot of a standard compound is also applied to the baseline. The paper is then moistened with an electrolytic buffer solution. The paper is then placed either in a horizontal or vertical position and in such a way that the two ends of the paper dip into a vessel of the same buffer solution containing the electrodes. When the current is switched on, the electrolyte on the paper acts as a bridge between the two vessels of the electrolyte solution. The charged components in the spot on the paper migrate towards anode or cathode. Molecules having no electrical charge form complex ions with ions present in the electrolyte and may show electrophoretic mobility. The paper is called as the electrophoretogram and is removed after some time and dried. The colored components get easily separated and are visible on the paper. The colorless substances are located with a detector. Now, the migration of these ions is of a charged substances depends upon several factors. The first and the foremost factor on which the rate of migration of charged substance depends is the structure of the ion. The size and shape of the ions influences the rate of migration. Larger ions move slowly and the movement of small ion with large charge is the fastest. The second factor which affects the migration of ions, specifically their rate, is the shape of the molecules. Size and shape of molecules influences the rate of migration. In case of ions, the bigger molecules move slowly. Crystalloids of small molecules are relatively unaffected. Colloids or macromolecules are absorbed by the paper. Next factor which influences the rate of migration of charged substance is the buffer solution. Ionic mobility is influenced by the concentration of the electrolyte solution. Generally, ionic mobility is inversely proportional to the concentration. That is, the mobility decreases with increasing concentration. Next factor which influences the rate of migration of ions is the electro-osmotic effect. On passing electricity into aqueous solutions of the electrolyte, water moves towards cathode, behaving as if it were positively charged. The positive charge of the solute also moves towards the cathode. The net effect is that the rate of migration of cation increases and that of anion decreases. Thus, substances and solvents are chosen which have no mobility of their own. However, electro-osmotic effect is generally ignored. Next factor which influences the rate of migration of ions is the effect of pH. The pH of the electrolyte solution governs the movement of ionic species. The effect is most pronounced when the substance contains both positive as well as negative charges. For example, amino acids. By suitable variation of pH, such substances can be made to migrate either towards cathode or towards anode. pH dependence of amino acid is as shown in the following figure. Next effect is the diffusion effect. When the substances are put on the paper, they tend to diffuse along the paper. The diffusion depends on the molecular size. Now, it has been observed that the diffusion occurs even when no potential is applied to the system, and also it is less with greater potential drop. Next factor is the effect of voltage. Voltage variation is the most important factor which influences the migration of ions during electrophoresis. The passage of current through the electrolyte generates heat which vaporizes the solvent of the electrolyte on the paper, resulting in the accumulation of salt on it. The evaporation of the solvent increases with the increasing voltage, which results in an increasing salt concentration on the paper. Thus, a specific voltage has to be chosen so that maximum separation occurs in minimum time, there is no generation of heat, and no evaporation of solvent occurs. Last but not the least are the environmental factors, the effect of environment, concentration of the electrolyte, chemical properties, ionic strength, dielectric constant, pH, temperature, viscosity, and the presence of non-polar molecules also have their independent role.